Continuing with lines, section 2.3, we're going to look at example 9 where again we find the intercepts and graph. Graph the equation 2x plus 5y equals 0 by finding its intercepts. So recall, we will let y equals 0 to find the x-intercepts. So 2x plus 5 times 0 is what? Just 0, right? I'll write that here just to show. But 5 times 0 is 0. So in other words, 2x equals 0 divided by 2, and x is 0. So we found that point, the origin. So we were finding the x-intercept, and that is here at the origin. Well, notice that's also a y-intercept. And in fact, if I let x equals 0, what happens? Then I end up with 5y equals 0 or y equals 0, and I get the same point. So this is the one point that both axes share, and now this line only has one intercept, right? So that's not enough to graph a line. I can't graph the line with that one bit of information that it goes through the origin. So I need another point to determine the line and a third point as a checkpoint. So let's let y equal 2 and see what happens. So 2x plus 5 times 2 equals 0. 2x plus 10 equals 0. Subtract 10. 2x equals negative 10. Divide by 2. X equals negative 5. So I have another point now. X is negative 5. Y is 2. So that will determine the line. Negative 5, positive 2. However, it's good to do a checkpoint. So let's get a checkpoint. This was our second point because we only got one from plugging in 0 for x and y. So we need a checkpoint. And for the checkpoint, I'm going to let x be 5. And we have 2 times 5 plus 5y equals 0. 10 plus 5y equals 0. 5y equals negative 10, and y equals negative 2. So now we have the point, would we say x is 5, y is negative 2. So hopefully these will line up. X is 5, negative 2, and indeed these 3 points are all on the same line. So this example was here to illustrate what happens when you're trying to graph using intercepts, but your intercepts are the same point, the origin. You have to find a second point, and then it's always a good idea to get a checkpoint. Okay, so our last topics on lines are to look at parallel and perpendicular lines and the properties of those. So let's recall from geometry, when two lines do not intersect, they are said to be parallel. Now this is two lines in the same plane, okay? Two lines in the same plane do not intersect. They're said to be parallel. Two non-vertical lines. Okay, vertical, remember there's something about those vertical lines with that undefined slope. So we constantly are kind of pulling them out of the definition. They get a special part of that. But if they're non-vertical, they're parallel if and only if their slopes are what? What do you think has to be true about the slopes if they're parallel? Well, they need to be the same, don't they? They need to be sloping, like here's my line, they need to be sloping at this exact same angle, at the exact same rise over run, otherwise they'll cross at some point, right, if they're not sloping the same. And they have to have different y-intercepts. Why do they have to be different? Well, if they have the same slope and the same y-intercept, they're not two parallel lines, they're the same line. Okay, so how would we know if vertical lines are parallel? You know, if you had two vertical lines that are parallel, what do they have to have? They'd have to have different x-intercepts, right? We don't say anything about their slopes because their slope is undefined. But if you have two vertical lines and they cross the x-axis in different places, they're parallel lines. Okay, so in this example, we're given the equations for two different lines, line 1 and line 2, and we're to determine, are they parallel without graphing them? So all we're going to look for is the slope and the y-intercept to see if they are the same slope and different y-intercepts. So line 1, 6x plus 2y equals 9. How can I determine the slope and the y-intercept? Right, we want to put it in y equals mx plus b form, and then I'll have that information. Subtract 6x, 2y equals negative 6x plus 9. Divide by 2, and I get y equals negative 3x plus 9 halves, right? So the slope for line 1, this is all line 1, the slope is negative 3, and the y-intercept is 9 halves. All right, let's do negative 3 minus y equals 3, and this is line 2, okay, negative 3x, sorry, minus y equals 3. Okay, so we want to get it in this format, so we'll add 3x. Negative y equals 3x plus 3. Notice I'm putting the x term first because that's slope-intercept form. Divide everything by negative 1, or multiply everything by negative 1, same result. Here I get a slope of negative 3 and a y-intercept of negative 3. So, are these parallel? Yes. Parallel lines. Because the slopes are the same, the y-intercepts are different.